Hey everyone, Mr. Newman here. We're just going to do a short video for the practice for this quiz. First of all, for graphs of function, this interval from -2 to 0, you can see from the graph, goes from there to there. Is this increasing, decreasing, or constant? Well, remember, it's as you're going to the right. We're increasing, so it's increasing. The next one, from 0 to 2, is from 0 to 2 right there, and that's as you're going to the right, so that is decreasing. The next interval, from 4 to 5, it's as you're going to the right, that is constant because it's not going up or down. On the graph above, -2, -1 is a local minimum because it's the smallest on its little valley there. But another local minimum is also 2, -1. So either of those would be correct answers. Is it an absolute minimum? The answer is yes, because its y value is the lowest number on the graph. So -1 is the lowest that blue graph gets, so it's an absolute minimum. Here, this tech ed student's making a catapult. What is the maximum height of the ball? Well, there is the vertex at the top. Notice height are the y values. We need to answer this question in terms of the y values, and it tells us that's 144 meters. 2 is not the height, so that's 2 seconds is not the maximum height of the ball. The x-intercept is right there. That's 5 seconds. What does it mean? Well, that's when the ball lands. It's not where it lands because the x is time, so it's when it lands. The y-intercept on the y-axis is the height of the ball. Notice I'm looking at the y-axis label again. In other words, that's the launch. That's also, if you put down, that's the roof of the school, how high the roof is, that's a good answer too. From 3 to 4 seconds, is the height of the ball increasing, decreasing, or staying constant? Well, that is from there to there. So if we plot those points, from 3 to 4 seconds, that is going down as you're going to the right, so it's decreasing. When you're graphing these functions, it's good to start from -2 to +2. So I'm going to fill in each of these values. When you plug in -2 into the function, don't forget the parentheses. You get opposite of -2, which is really +2, so you get 6. And -2, 6 is the first point. We're going to do the same thing for each other one. Plug in -1, you get 5. Plug in 0, you get 4. Plug in 1, you get 3. Plug in 2, you get 2. So I'm going to plot those points. Notice they should make a line because I know that equation is linear. So we have that straight line. For the next one, I'm going to use the same points, plug in -2 to make this video go a little quicker. I'm just going to plug them in very quickly so we get those values, plot those points, and that's what you should have gotten. On both of these, you can use the calculator to help you do that more quickly, but even if you don't have a calculator, you can do this by hand just like that. For this function, the easiest is to type into the calculator. If you do that, I need you to tell me exactly how you typed it in. I'm going to actually do it by hand for those who don't have a calculator. So -2 squared, you must follow GMDOS. We do the exponent first. -2 squared is +4. 4 divided by 2 is 2, and 2 times 9 is 18, so that first one is -18. So we get -23. If you write out your work like this, you don't need to explain it anymore, but if you type in the calculator, you need to say exactly how you typed it in. For this last part, the common types of functions, graph 1 is decreasing linear because it's going down as you're going to the right, so that is B. Graph 2 is positive quadratic. That's because it's concave up. Remember, up like a cup, down like a frown. For the next table, you notice how it's dividing by 2, so it's exponential decay. It is not adding by the same or subtracting by the same amount every time, so you know it can't be linear. And if you notice, dividing by 2 is the same as multiplying by 1/2. So you're multiplying by 1/2. 1/2 is the common ratio, so it must be decay because it's going down. The next one's adding by 2 each time, so that is increasing linear. The third one, situation 1, is there's our equation. So 2 to the x, you see the x is in the exponent. Also, it says it doubles every hour. So you know that's going to be exponential. It's going to be growth because it's doubling, so that's growing. And lastly, our last one is quadratic because you notice it said he shot a basketball. If we draw a picture of that, it's going to look quadratic, and you also have x squared in the equation, so it's going to be quadratic. It is concave down like a frown, so that is going to be negative quadratic. Thank you for watching.